Let's do a quick video walkthrough of the problem that we did in class today. So this is lecture, I guess, 7, where we looked at the hydrogen and palladium charging problem. So I'm not going to go through the whole problem. I just want to show you the Excel spreadsheet so that you can go back and double check yours, make sure everything is set up correctly. So recall that we set up our constants in Excel, and so far we've got a surface value that we define, an initial value through the thickness of the material we're looking at. In this particular case, that would be palladium. These concentrations in this problem are atom percent, and this represents then 0.2 atom percent of hydrogen as a concentration in the palladium, and there's no initial value. Then we've got our diffusivity, that's just given. The number of nodes in this problem that we're to use was given, the thickness, and then the other values we calculate. So the Fourier number, for example, is the diffusivity, okay, times dt, our time step, divided by dx squared. And here's our dx value. And we'll take a look at those. And you can notice in my equations, instead of cell references, I've got names. So that was one of the things that we did as well. If you click in where these values are, you can, if it still has a cell reference, you can click in that cell reference and then just type in a name. So this is CS, and we've got C0. The Fourier one I hadn't given a name yet, so I'm going to leave it like that so I can show you how to use the cell references as constants if we don't have a name. The diffusivity, I got my dt, nodes, thickness, dx, and my maximum time. Okay. All right, let's see what else. So the Fourier we talked about. The thickness is just going to take, thickness is defined in the problem. The dx value is going to take the thickness, and it's going to divide it by 1,000 because my thickness units here are in millimeters. Okay, and that'll put me in meters, and then I'm going to divide by the number of nodes minus 1. Okay, so that'll give me my correct thickness value, my correct dx between nodes. Okay, so you can see that here in terms of millimeters. And let's see, maximum time is given by this equation. So 1/2 times dx squared divided by the diffusivity. Okay, and diffusivity in meters squared per second. So this says my maximum time step is 5 seconds, and so I've gone and maxed that out here. If I change my time step, then the value that gets changed, you can see here, is the Fourier number. All right, so in this problem for 1D diffusion, the Fourier number needs to stay below 0.5, and that's automatically met as long as my time step is no greater than the maximum time step. So that's all of those set up with the names, again, except for the Fourier number. So when I use the Fourier number, because I need that in my equation, let's just show one of these equations here. So I'm looking at node 3 at 5 seconds. So notice since I didn't name the Fourier cell, then I've got to use the dollar signs to fix my column and fix my row. Okay, so that allows me to use that, and then I can copy this equation across, I can copy it down, and the reference to B7 won't change. All these other references will, and we want them to update the formula as we move across and move down. That's the other thing with the formula. Just notice that I'm looking here at node 3 at 5 seconds. Okay, and then my formula is looking at the previous time step here at 0 seconds. Okay, so it's looking to the left, center, and right of the node that I'm interested in. So that's true of any node I click on. So if I look at this one, it should be looking up here at the previous step. Okay, so there it is. So that's one double check just to make sure it's looking at the previous time step, left, center, right. And then that's all added back to the value I had in that previous time step. So that's my internal node equation, and that equation is good through nodes 2 through 25. So if I was to type that node equation once here in node 2, then I could take that and just drag it across all the way over here to node 21. And then as long as I have this column already here, I can just go and double click on this corner, and it automatically filled that equation all the way down to the bottom of my sheet. Well, down to the bottom of this column, which in our case is 1112, row 1012. All right, I just jumped down to the bottom of the sheet, jump back up. I'm doing that by holding the control key and then using the up or down arrows. I can also do that by holding control and hitting the the right arrow, take me to the last column in my sheet, and back to the first column, control key, left arrow. Okay, so that's how you can move down pretty quick. It's also quite handy when you want to copy a row and move it across. So let's do that too, because in this problem we're supposed to have 26 nodes and I only have 22. All right, so this node I'm going to get rid of because this is a surface node and it might have an equation that I don't want in my internals. So I'm going to get rid of it altogether. Don't worry about the reference. And then I'm going to take this one and I want to hold Control Shift. Actually, let me highlight a little bit more because since there's nothing here. So let me highlight this one and just down some. Okay, now I want to hold Control Shift and then down arrow. Okay. And then once I've got that, okay, I'm going to have to fix this reference cell. Since I deleted that, it's not happy with me. Okay, let's fix it. Okay, so I click in it and see what's going on. I can see that this is supposed to be an internal node and it doesn't have a reference here. Okay, let's check this one. That one looks fine. So let me just copy that over to this one. Oops, that didn't copy. I think I actually moved it. Let me copy that one over. There we go. All right, so there's my internal node equation. I could have just retyped it, but there it is. That one's fine. Okay, it's an internal equation, so it's supposed to look over here. I just don't have anything over there yet. We're going to fix that in a second. All right, again, double click here. Make sure that copies all the way down correctly. And this one down correctly. All right, so I had two reference issues. This one says inconsistent equation. I'll copy that down. All right, we should be fixed finally. Let me select these and then again Control Shift down. Okay, I'm going to ignore that. And then let me just copy this across. Okay, get rid of this chart down here. Okay, so let's go back up, Control arrow. All right, so I copied a little further than I need it, so I can go ahead and just delete these two. And I need to now fix node 26 to be a insulated node. Okay, and I have my equation right here for it. So let's just go ahead and do that. So this is going to equal my previous node right here plus 2 times the Fourier number. So I'm going to need to go over to that one. Here it is. And I want this to be a constant. So the shortcut, I can just hit F4 and that'll put the dollar signs in for me automatically. Or you can just type them in manually. Times, and I got C25 minus C26. So that, again, that's the previous step. So that's here minus there. Okay. So I've got that one fixed. And now I can go ahead and copy that down. And now my sheet should be good. So I've got my extra column here. I'm also going to go ahead and Control Shift down, select everything. And I want to just highlight that background color, remind me that this is a surface node and has a different equation in it. These are all internal nodes, so they all have the same equation. And then this one was the surface node with the value being fixed. Okay, so that should update my sheet nicely. My check is that at node 26, I'm here at 0.5 millimeters, which is what my thickness is supposed to be in this problem. All right, so we've got all that fixed. The sheet looks good now. And in this problem, I want to run this for over 3 hours. So one of the things I could do, let me just give myself a little space there, is maybe I want to go ahead and make a row here of hours. And so I'm going to go do that. I'm going to just take this, seconds divided by 3600. Okay, and then I'm going to be able to just double click and it will go ahead and fill all the way down for me. So let's see where we are. Control down arrow. All right, so I only made it to almost 1.4 hours. So I'm going to go down to 3 hours. So what I'm going to do is I'm going to go across here, select all my data on that row as well as my times, because I want those formulas to continue down as well. And then I'm just going to go ahead and drag down a bit. I'm not sure how far down I need to go. I'll just go down to there and see what happens. Okay, I got plenty. I'm at 4.8 hours. Okay, so that's fine. No reason to get rid of it unless your sheet is particularly slow. Actually, I might get rid of it just because it'll make it easier when I want to plot to find it if it's my last row. So I'm going to go ahead and select across. I'm going to delete all these. I'm going to do the Control Shift down. I've highlighted them all, and I can just go ahead and delete them. All right, so there's my 3 hour row. Control up arrow, get me back up to the top. All right, so I think that is most everything we needed. Insulated node, internal node, fixed node, we added the hour column in. And let's see, the only other thing I can think of is just to make this plot of node 26 over the 3 hours. So this is a little bit different plot than we had before. Instead of highlighting the distance and then highlighting rows using the control key, we're now going to highlight, I'm going to highlight the hours. Okay, Control Shift down. And then I'm going to come over here and highlight my last row. So this one, I don't think I have a shortcut for because I've already got one highlighted. So all I can do is hold the control key, click and just drag so that I can highlight this one. And it should go fairly quick. So we'll get it up here to the top. All right. Right to there, right? So that's where my time started. And now I can go ahead, I'm going to put it over here, insert my chart, and there it is. So there is the time over 3 hours and the concentration value of hydrogen as it's being charged into my 0.5 millimeter sample for that node 26. And you can see that actually I'm reaching the 0.2 value almost there at 3 hours. So I'm getting very close to finally getting a steady state. So once this reaches 0.2, it won't change anymore, right? Because my surface value is fixed at 0.2. So when it's 0.2 everywhere, then I'm at steady state. I won't get any more loading of this particular palladium foil. Okay, so that's the walkthrough. Hopefully that will help if you're running into trouble with any of your equations. Remember to always double check your maximum time and make sure that the time that you set is less than that value.